Hi everyone. Mm, Good morning. I'm Andres Mauricio Alvarez, a student and the environmental engineer from the University of Antioquia. I'm the person in charge of the presenting the result of this investigation, the global estimation of the effective plant routing, the implication for the hydrological modeling research in Australia, Sydney, Australia. They estimate the effective plant routing deep CR using a carbon cost benefits model across the global terrestrial ecosystems. So, global distribution of the CR and relationship with the climate. Plant routing deep CR is a key parameter in hydrological and biochemical models. Just the global epithelial distribution of the CR is layering unknown due to the difficulties in this direct measurement. Additionally, CR's observations are usually only representative of the single plane observable plants. We can differ greatly from for the effective CR over modeling unit. Catchment of the gray box. Here we provide of the global parameterizations of analytical CR model that balance the marginal carbon and the benefit deeper. So, grew up the produced chemical and climatological global CR map to the direct CR estimated. We applied of the estimate of the CR in the highly transparent hydrological models. But it is important to recognize the center of the excellence for the climate system of the Australia Research Council sites, Sydney, Australia, how the institution is responsible for this research. But estimate the main annual actually evapotranspiration E across the globe. So we then compare the estimated E with the both water balance base, the observation at 32 major catchments and satellite grid box retrievals across the globe. So the problem to be resolved in these investigations. They wanted to be resolved in this investigation in the synthesis is the terrestrial ecosystems. The plant rooted deep CR primarily determining the active soul. Some does is the potential to return back into the atmosphere via plant transpiration is also profoundly effect to the exchange of the energy covered between the land surface from the atmosphere. Do the close coupling about the terrestrial, I'm sorry. Water energy and carbon cycles, besides the critical roles on regulation of the lab surface atmosphere interactions, are core parameterizations of CR is essentially many hydrological and biochemical model of the successfully simulate surface process, such as deep drainage and runoff generations. The species is important in the control of terrestrial hydrological and biochemical process. Unfortunately, the global distribution of the CR as its relationship with the climate, soil, and the plant, the physiological characteristics remain largely unknown. This is primarily due to the difficulties in this direct quantification of the CR using on the field approaches, especially for the deeper rooted plains. So the scientific basics of the optimality model is that for a given climate and soil environment, the optimal CR allow plants to the minimize their water stress over the long time period and to maximize transpiration and or productivity. This model has been widely used to examine the role of the climate edaphic physiological factor on the CR, nevertheless. So they have not yet been extensively texts to the problem applauded across the different environments. I'm sorry, one of the few existing global explications of the optimal model of the CR presentation of the Kyoton and Heyman in 1998, and later updated the Clayton in 2004. So, estimator of plant prototype using Govern's carbon cost benefits model. So, the objective of this study are first is proving a global parameterizations of the WorldMass 2008 model to produce a global CR map and disseminate climate control of CR. Second, compare CR estimate are here with two other existing global CR data sets. CR estimate by optimally model Clayton and up at the scale from in situ measurements and examine how different CR parameterizations affect hydrological simulation across the global terrestrial ecosystems. So, what is this? Estimation of the plant rooted deep is using Gaussian carbon in the beneficial. Rooted deep is predicted using a carbon cost Bennett model developed in the Gauss-Watt 2008. The fundamental idea of the Gauss-Watt model is that deeper roots permit plants and the abscess more soil moisture which allows plant to avoid the water stress for the longer times during meteorological dry periods and therefore achieve greater growth of carbon uptake. On the other hand, the construction and maintenance of the additional roots consume carbon. As a result, there must be optimal rooting deep on which the marginal carbon benefits. So associated with any additional root balance, marginal carbon on the roots follow Gupta's average on the cost on the benefits on the plant roots can be written receptly as this equation right here. So we calculate PT using the hybrid dual source EP models of the Guana-Wilson, which is the physically basic model that partitions EP into the PT potential evaporations from the soil and the canopy interceptions and requires only readily available near surface climate, radiation, air temperature, vapor pressure, and wind speed, and vegetations. That improves the result equation on the stimulus CR is that here. I'm sorry if my face block the letters right here. I'm sorry for that. So determining model parameters. So this several parameters need to determine a priority applying the model to estimate CR root respiration rate CR. Was quantified using the Q10 equation, which is the function of the air temperature. This is one right here. And obviously, it's not. This is the model of the parameter we uses right here. So. The probabilistic steady state solution of the Papareto stochastic dynamic soil mixture model in the Papareto in 2004 share a similar form with the Boudico curve. Papareto parameter use X stick of C per Papareto et al. 2004. To distinguish it from the root respiration parameter used in the Gauss-Watt CR model, This is a function of the CR and age. An exhibition is close in a relationship with the subdury parameter n and with the graphics. So right here, it's not complex, really. So, global distribution of the CRs in relationship with the climate, and the special distribution of the CR and the estimated from the Guswat carbon cost benefit model in the show in this figure. So, with the global mean rooted deep of the 0.678 m deeper roots. So are generally observed in tropical and subtropical regions, including the Amazons and Congo, basin and the Southeast Asia is contracts in the more arid and or cold regions. The CR values are usually less than 0.4 meters, suggesting shallower. So hydrologically, activity soil layer on a smaller storage capacity. At the bioma level, the deepest CR is observed in the EBFs, which they generally occur in tropical and subtropical regions. With a high CR spatial heterogeneity. Oh my God. Genéticamente, creo que dice heterogeneity is new word to me. I'm sorry for that. Following by the DBF savanna. So for the remaining 7 vegetation types, there is a means CRR or lex. So then 0.6 m. The shallowest mean CR was found in the short one, with also encompasses most of the tundra ecosystems in the boreal regions according to the Maldives and cover classifications. Right here is the discuss and the results. This is the cues about the investigation right now. I'm sorry. The TechCR Guswap to examine how different CR parameters affects hydrological model behavior. So they use the BCP model with the different CR parameterizations to estimate means annual E globally. And the catchment scale they estimated E from the BCP model combined. So with CR Guswa agrees very well with the observed E from the catchment water balance. So on average, EBCP Guswan could explain 24% of the spatial variation of the observed in E. This right here. And root mean square different MSD, and means B is defined as estimated means observed means. So of EBCP, Guswa are 74 and 104 ER 21 respectively. So this result suggests the applicability of the Guswa carbon cost benefits model of the CR of the estimated here in the effective for the hydrological modeling. So across all the global terrestrial ecosystem, right here, you can determine right here is on. Right here. So CR is important parameter in the hydrological and biochemical modeling to quantify the exchange of the carbon, water, and energy between the air and the atmosphere. However, the determination of the CR is occurring hydrological and biochemical models. So especially when they apply globally. Yeah, it's a big study. It's larger base of the lookup table approach in which CR for each vegetation type of the fixed value is quantified according to the literature values of the mean biome, CR, and soil tester information. This approach would determine CR suffer from two main issues. So, second, the lookup the table approach the problematic in the scale mismatch between the CR observation that are used to obtain the human average and the real modeling observing CR usually represent CR of the single plan of the several plan, but does not represent CR over the modeling unit. So consequently, CR from lookup the table, look at the different grading from the effective CR over the modeling unit, that is the model hydrological and ecological mindful. So the same problem also exists in CR, a chain which is on the upscale CR produced by a base of the observed rooted deep. This explains the overall large value of the C chain that the CR goes one in particular for the no foreign ecosystem. So where is the vegetation covering the usually low? So the conclusions about that. So this study provides a global parameterizations of the carbon cost benefits model of the Guzman to estimate the effects plan rooted deep across the globe. We find the shape of this distinct CR between biomes and high spatial heterogeneity. I'm sorry. Is the word I don't understand really. So heterogenesis, algo así. Of the CR also exists within each biome demonstrating the inadequacy of the using lookup table to define CR in the state of the R land surface. Hydrological model consists with the inverse modeling. So deeper rooting deeps are found in areas where annual P is similar to a P for the dry area CR. The larger is constraining by the availability of the carbon or for the stream width environments. A shallow root will effectively safety the atmospheric water demand. So in addition to annual sums, the seasonality of the water supply of demand also play critical role on the determining CR, with areas having a longer dry season. So water supply to demand are demand and are of the phase usually exhibiting a deeper CR. So we then adopt the parsimonious hydrological model to the text of the effectiveness of the CR goes one in hydrological modeling. We find generally good performance of the BCP model when incorporated with the CR goes one in producing the observed satellite derived mean annual E across the globe. So it is. So thanks to everyone. It's really complex for me to get rid of my native language to face a subject that I'm barely learning, but I think that the subject of the hydrological represent a challenge, but a personal and for all humanity. So we must learn to interact with our water. So thank you very much to listen. See you later.